Around Christmas last year, I bought myself this book. It's called Programming Boot Sector Games, and it's about writing 8088/8086 Intel assembly games from scratch, starting from very simple projects and iteratively, step by step, coming to a game of complexity like Pac-Man. And that's exactly what my motivation back then was, to get to know the low-level workings of computers a little bit better, to learn pretty ancient Intel assembly in a practical way, as I didn't do assembly programming before. And as I always say, there's no better way of learning something than writing a game. So I read the book and I recommend it. It's very satisfying to read and practice, but for some time I just left the topic. The idea of writing an emulator for some platform was still bouncing in my head occasionally, but it never materialized because I had this notion, which is still correct, that writing an emulator involves spending a lot of time reading device-specific documentation. Now, just recently I've learned about CHIP-8 platform. It's more of a platform specification because CHIP-8 programs are usually run on a CHIP-8 virtual machine, and hearing about virtual machines may make you think that it's some pretty modern platform, but it's not. It comes from 1970s, and those VMs would originally fit in less than 512 bytes. And among the games that they could accommodate were, for example, Tetris, Brick, and Pong. Now, here's the best part. Writing a CHIP-8 VM/interpreter/emulator, whatever the term fits best, is actually that simple that it's recommended as the first project for people wanting to develop emulators. And guess what? I myself wrote a CHIP-8 VM in less than a few hours, and it only could handle less complicated runs, but at least it could run. Perfecting it would certainly take more time. I also owe it to a very good documentation that I found. So I wrote an emulator, or VM, or interpreter. What's even better than having an emulator? Having an emulator inside the game. Because of the entity component system nature of my codebase, I created an emulator sync entity composed of position, quad, and mesh components. So far it looks like all the other props entities in the main menu, like GitHub link or main logo, but the secret ingredient is the scripting component, which gives the emulator sync its specific logic. So I created emulator sync script class extending from script base, I implemented the update method, and I added chip member. In the constructor, I load the program, the CHIP-8 instructions, and because those CHIP-8 programs are so small, I don't care about research compiling them into header files. I just call hex dump on each of those ROMs and copy paste the contents into the vector. Now in the update method, I update the tick timer by delta time since the last frame, and so often I call the tick method to progress the emulation. Just below I create RGBA frame buffer, where RGBA is this helper structure that I created. It's just 4 8-bit fields for each color and the alpha channel, and for each pixel of the chip frame buffer to the boolean array. If it's true, then I create a totally white pixel or a totally black pixel. Just below I bind the texture and upload the contents of the frame buffer. And below I update input in the input registry. Needless to say, it's not going to the master branch, just a fun experiment for the sake of learning. If I were to extend the emulator, I'd probably add some interface for debugging, maybe using IMGUI to display stack, to display instructions, registers, frame buffers, sprites. Anyway, that would be it. Bye.